Hello. So I see everybody in the monitor here. So at least I can see you. Can you hear me, beautiful people? Some feedback from the chat. Hello.
Yep.
Everything is broken. Yeah. Okay.
No, I should have fixed
So
everything.
okay, I can hear. Thank you, Mark, for the feedback. So, good evening, everybody, or good night, or good morning, depending when are you watching this and where are you actually enjoying the live stream. So today, Sebastiano, you need to do your thing because I'm not able to do my. I mean,
Yes.
it doesn't work.
Just give me 1 second to
Yeah.
make Rahul
I'm
a bit
kidding.
higher definition than it was. No, that's just Skype is not helping. It's fine. Doesn't matter. I'll fix it later. Hello, everyone, and welcome back to Code with Italians. When we take a break, things break. I think that's our new motto. So no more breaks until the end of the year. Today, we are here with Rahul from Google. He is going to be talking to us how baseline profile work, how what they are to begin with. I think that's also fairly important intro to do. And then we are gonna try and see if we can make our app faster. I'm so looking forward to that. Rahul, do you want to intro yourself while I try to fix the remaining streaming issues?
Sure. Yeah. Hi, everyone. My name is Rahul. I am an engineer at Google. I work on the Android X performance team these days. I also used to work on Work Manager. So if you've seen me talk about Work Manager before, I still consult with it. But like my day-to-day work has switched to baseline profiles and performance-related stuff. Today we'll be looking at what baseline profiles are, hopefully, and then we'll take a couple of real examples, and then we'll see how to generate them, and then how do you make your app faster.
Awesome. Thank you. Now we can also see you a bit better in the meantime. Okay. So, Ivan, do you want to do the Ivan thing and then we can get started because I'm so super excited about this.
Yes. So quick Ivan thing. So I'm just gonna drop links in the chat as we go, and you're gonna find the links in the description. I want to try this thing. Let's let you just bear with me for a second. Subscribe. Can I do this? Is it happening? I don't know if it's happening. Is it still working?
No. Yes, it is. Yes, it is.
Yeah, it's working. Okay.
I remember to fix the URL 2 weeks ago. Ha.
Bravo.
Yes.
To support the channel, there are plenty of stuff. You can watch the videos on YouTube, and Google is gonna give us cents. Yes. we are not Mr. Beast, so we don't do money with YouTube. But you can support the channel buying the stickers that you can find on our coffee store. You can buy the t-shirts that you can find on our Made in Italy t-shirt store. I'm just gonna drop every link in the chat, don't worry. And the cheapest way that you can support the show is if you have an Amazon Prime subscription. You can connect your Amazon Prime to your Twitch account via your Amazon Gaming account. Basically, it's all one thing because Bezos bought everything. So now Bezos also is giving you the money to subscribe to one Twitch channel every month, and you can pick us. And that will go in our fund to buy stickers, ship stickers, and get basically swag that you can get at conferences and things like that. And that's it. So El Ivano. So, hola Mark. Gracias por... Raúl, yo estoy aprendiendo español.
Did I live translate?
Wow, that would be interesting.
I mean, I understand what you're saying. It's fine.
Yeah, fair enough. So, bienvenido a todos. Nueva puntada de Código con los italianos. And yeah, let's keep the ball rolling, Sebastian.
This never stops being embarrassing.
No, I mean, even at some point, I'm gonna be like BA something bullshit at Cervantes, so things like that. It's never gonna be awkward.
Never, never, never.
Anyway, let's do this, Sebastiano, because I
Yes.
need to put this stuff in my
Yes.
apps. So
Yes.
I want to
Yes.
know how it works.
Okay. So in a second, we're going to be sharing Rahul's screen. And Rahul, are you ready? Can we? Do you have any weird confidential stuff we shouldn't be seeing? No?
No.
Okay.
Should be good. Yeah.
Off we go then. Cool.
All right. If there's one thing that you take away from the day, just it's this link. It's developer.android.com/baseline profiles. It's a short link that'll bring you here, and it'll just summarize everything that we'll talk about today. And then you'll have a lot more context on what it is that we are going to do. And let's actually switch to some context, like why are baseline profiles so good at what they do, and that's kind of because of the way the runtime works. To give you some history, Froyo, for people who were developers back in the day, was a huge deal for developers because that introduced the just-in-time compiler. I don't know if you remember, prior to that, we ran in interpreted mode, and things were not that fast. But come Froyo, all of a sudden, code magically got faster for everybody, which was really great.
It's the best kind of improvement, the one I don't have to do anything for.
Exactly. So it's one of those improvements where your app was just just the moment your phone upgraded to Froyo, you would see the app just perform much better. And those are the best kind of performance improvements, just like Seba said. So the just-in-time compiler kept adding more and more optimizations, and the way that works is, as your code is executed, starting with interpreted mode, we find out what parts of the code are being executed again and again, and then there's some threshold that makes or deems a method or a class as hot. And once the class is deemed hot or a method is deemed hot, the compiler takes that and then optimizes it further and produces more optimal code. So when the next time you invoke that method, we invoke the optimal code path instead of running the code in interpreted mode. And so that's why your app becomes faster. But if you followed my conversation this far, you realize that there's parts of your code that still start off in interpreted mode, right? Like, so the code has to be interpreted to be identified as hot, and then we compile the code to using the just-in-time compiler. And so that was Froyo. And then I think in Android, I'm trying to remember, was it Lollipop? That is when they introduced full AOT. And this was to sort of solve the slow start problem, right? So the way full AOT worked was at install time, there was the new compiler that shipped on every single Android device called Dex2Vote, and that converted your Dex code to optimized Dex files. And those optimized Dex files would be used for app launch. Now, there's two minor issues. That we need to store the compiled code, because once Dex2Vote runs, the Dex code that's converted to ODEX, that ODEX needs to be stored. And remember, Android Lollipop, storage is not cheap. It's still fairly expensive, especially in some markets. So kind of important to think about. And also running a compiler that's an optimizing compiler that does not know which parts of the code are important, which parts of the app are important, and trying to optimize the entire app, right, is not easy, especially on a resource-constrained device. And so we kind of backtracked from a full AOT because we got the infamous optimizing Android apps dialog. I don't know if you remember that, but I remember that. Every time you got a system update, we had that crazy long spinner that prevented you from using your phone.
You still do. On some Pixel devices, you do get it, and it's incredibly annoying.
It is annoying.
I will not name and shame, but you do get it, and everyone knows what I'm talking about.
Yes. So that was a problem, and so I think in Nougat, we decided to do sort of the best of both worlds. So we would try and use the interpreted mode to identify the parts of the app that are important. And rather than throw all that information away, after the just-in-time compiler kicked in, we basically store that information in what we call a profile. And a profile is not something magical. It's just a list of classes and methods. kind of looks like this. Let me share what a profile actually looks like. Okay, hold on. Let me zoom in a bit. Is that better?
Yes, thank you very much.
All right. Let's see. Let's see what they actually manually create a baseline profile. Yeah. So this is kind of what a profile looks like in its human readable form. If you notice this text.
I like the loose definition of human readable that you just used there.
Yes, it's human readable in quotes. It's human readable in the sense that you can read it, but it won't make any sense to you, right? It's not meant to. It's still for a compiler to use. So, and the way you interpreted this is like the HSPR flags. H stands for hot. S stands for that this method was used during startup, and also P stands for that this method was used during post startup, so like after the initial launch. And L is just a JVM prefix. So we use the JVM descriptor syntax. So L, Android X, compose runtime, compiler, impl. This is just a class. So this is basically saying there's a class called composer impl in Android X compose runtime, and it has a method update value that takes an object and returns a void. Returns a V. V I think stands for void. If I'm
yeah, should be, if I'm not mistaken.
Yeah. So
if it's the same as Dex, then
yes,
should be. Yeah.
It's the same. It's the same.
Yeah,
so
okay.
That's how you're supposed to read this. And then when you see something that looks like this, which is an L prefixed line, it just means that this class is generally important for to be preloaded by the class loader eagerly. So because this is being used early enough during the application startup lifecycle. So we literally have these classes and methods, and once we have these in the profile, then the compiler that I talked about can just focus on compiling the subset of these methods that are defined in the profile, rather than looking at all the classes and all the methods in the APK. And that speeds up the process a lot faster, because you're compiling a subset, so it only needs to look at that, and then it can keep discovering what the important parts are as the user's using more of your app. So let's say you're only using YouTube to view videos, which many of us do, but only a few of us create videos, right? So then the important parts of the code that would need to be optimized are the viewer, and not the creator flow, because that's like far less used. And so I think it's totally, for you to choose, it's totally up to the runtime to figure out like what the important things are from a user's perspective and kind of prioritize them in the process of optimization. I'll just pause here in case Seba or Ivan have any questions.
So more than a question is more, I'll try to recap what you said and see if I actually understood.
Right.
So the baseline profile will contain a list of classes or methods that are important to be compiled ahead of time. And that's because they're used often, or they're used in a critical code path that is needed, for example, a startup.
Right.
And this list is generated essentially by tracing what stuff is used when you launch the application.
That's right.
And then you kind of get this like text file that is a log of everything that was used during startup.
That's right.
Okay.
It's sort of that, but not quite. Okay. Let me.
It's never that easy, is it?
So the runtime isn't very helpful. It doesn't actually give you those classes and methods unless you ask for them in a very specific way. This is because the runtime treats it. It's because they treat all this information as implementation detail, right? So profiles, it's interesting. They have an interesting history. They were never meant to be used this way. They were only internal information for art to save and create profiles. To compile profiles after the just-in-time compiler kicked in. So the typical workflow would be user uses the app, the device goes idle. The just-in-time compiler, essentially, when it ran the app, dumped all the information that should have been compiled into this file with these list of classes and methods. And then once the device went idle, there was a job scheduler job that ran on the device that picked up these rules, compiled them, and created the ODEX files. So the next time the process spins up, you have the compiled code that replaced all the interpreted code that would have been used otherwise, if that makes sense.
Got it. Okay. Yeah.
So that's the typical workflow. Starting Android P, I'm trying to remember the version number, like Pi. I'm going to use desert names because it's easier for us.
While they still exist.
Yeah, while they still exist. So starting Android Pie, I think we said, hey, wouldn't it be nice to actually crowdsource some of this information? And rather than start off from scratch every single time when an app is installed, like, wouldn't it be nice to basically provision a profile that is very likely to make sense on that app for that app version? So let's say we're using, Android messages, right? And then there's lots of people who use Android messages to read and send text messages. And if we have profiles from devices that are similar to yours and that run an operating system version similar to yours, we can sort of crowdsource that information. Once that information ends up with Google Play can compile the list of classes and methods, and then the next time someone wants to install Messenger, they get the APK plus the list of profiles that should have been there at start, and then that gets compiled. So that's what cloud profiles are.
I start feeling that there is a but.
Yes, there is a but.
Of course there is.
There is a but. Unfortunately, the profiles only kick in. So first, there's a few delays built into the process, right? Because the first time Messages releases a new version of the APK, there's no profiles. There's no profiles to even crowdsource also, right? We need users to use the device a little bit before the just-in-time compiler can identify those hot paths. And then we can get profile information from the field to crowdsource. So there's a cohort of users that will never get a profile. That is something that is true. And then once there's enough profiles, those have to be uploaded and aggregated by Google Play, which takes time. So there's like a couple of weeks worth of delay built in there because all these profiles, it's a massive MapReduce job that's picking up these profiles from every single client, sort of aggregating them, figuring out what's important, what's not, and then storing the profile information. And there's even more complexity because profiles are actually specific to an operating system version, and they're subtly different profile formats as the platform evolved. Because remember, profiles were never meant to be originally never designed to be used this way because they were just art implementation detail to speed up things that art would have done anyway, right?
Right.
So now we're sort of bootstrapping the process, and so this job would essentially create profiles for every operating system version. And then when a new user came along and wanted to install that version of the app, that's when they would get the profile.
So does the fact that you needed to get users to use the app on their device and enough of them to send the data to Google Play so that Play would have enough data to generate the profile that works for you, does that mean if you have, you're probably fine if you have a device that is very widespread, but if you have a device that only you have, you're kind of screwed.
You're out of luck, right? So clearly that's the problem. Another problem is Google Play kind of considers install size also as an important factor. So it prioritizes install size for an app, which makes sense because the more people use the app, the better, the more important profiles are. So that's another consideration. I don't know if that's still a consideration today. It used to be a consideration back in the day, at least. And then there's a few other things that there's also a few other things where how actively is the user using your app? So if you're an app that is only very rarely used, then the odds are profile generation on that for that app on that device takes time. Like if you're not an app that is used daily as a habit, right? And then so for example, like an app like YouTube or Maps is very likely to get profiles quicker because that's something users use day in and day out as part of their lives. But then if you're an app that is less frequently used, let's say there's many apps that I can think of that are like only
our
used
app
for,
that nobody uses because it's not on the store yet.
That's right. That too. And also, like, we've sort of been making the assumption that there is Google Play to begin with, right? There's like an entire population of devices that for whom Google Play does not exist. So what about them? Like, how do we help them? So there's like things in the cloud profile pipeline that were less than ideal. So, and then I think at the same time, we were actually facing a few headwinds, right? Applications were getting bigger. So there's more code to optimize. There's more code to trawl through to even determine what is important, what is not. At the same time, as the applications are getting bigger, the devices are not getting as faster, because like if you were to draw how fast Android applications are in typical, like how fast Android devices are in typical, like the application size is like a far steeper curve than application performance, or runtime performance in general. So as the runtime is improving, performance is barely catching up with like increasing app size and complexity, right? Because Android applications are getting more complex, they're getting larger, and there's also a lot more unbundled code, which is different. So one of the fundamental premises of the Android platform back in the day was most of the code that the user or that the developer is writing is just targeting the framework code, right? And the framework code is special because the framework code is fully optimized ahead of time. So things that are on the system image have like full AOT compilation treatment, right? So when you use a class like Vue or or animator or a class like animator set, they're all ahead of time compiled because those classes are coming from a class loader that is forked from the zygote. It's not actually, it's basically like a copy of the class loader that came from the zygote, right? So those classes are special, and therefore if you're just calling those classes, your code is optimized too, because you're just delegating to those classes. But things like compose happened, and which meant that a lot more of app code became a lot more prominent part of the application. So like there's less and less framework code. While there's framework code, a lot of the Android libraries are getting unbundled. As a result, we have to fix the ahead of time compilation problem for app code that can't be optimized the same way that the platform code can, if that makes sense.
Yeah, it does. I think maybe this is a good time to start taking a couple of questions from the Slido. As a reminder, you have the link in the chat. I'm just gonna repost it just in case. Thank you, Ivan. You're too fast.
No, it's not me. It's the bot.
It's the bot.
it's the bot. It's like the 90% of the users on our chat are bots. It's like on Twitter, right? It's
no. We don't talk about Twitter.
We don't do.
We don't talk about Twitter.
Okay.
So I have I'm gonna keep the one specific to baseline profile for later, but there's a couple that are about how this mechanism we have described so far works, and specifically one is background Dex2Auth part of the OS?
It is. So it is part of the OS. Essentially, the runtime kicks off a job, which is set to device idle, and once the device is idle, it kicks off Dex2Auth. It's just a standard Dex2Auth compiler execution, but it happens to be in the background because it's happening through a job that's triggered when device is idle. That's why it's called That's why it's called BG Dexopt, as if it's a special case, but it's really not. Think of it as a general case of Dexopt.
So it's just someone was like, okay, we have Dex2Auth done. Should we just run it during the night or something?
Yeah, exactly. It's like let's not prevent the user from using his phone, because running the compiler makes your device. I don't know if you remember, it used to make your device hot too when you saw the optimizing apps dialog.
Yeah.
I don't know if you touched the back of your phone, they used to get like super hot, and that's because your CPUs are getting hotter too as a result of compilation. So.
I can imagine during Dex2Auth the cores are like shouting, ah!
Sebastian, it's a feature.
It's very scientific.
Those, cold winters. Right?
Yes.
For those cold winters. So how can we add this feature and you just run the CPU like madman?
So that was the first question. There's another, maybe one, I think, that is relevant for now, which is if every time a hotspot is found and it's added in the profiler, shouldn't I add them all from the start, or did I misunderstand how it works? I don't know if this is for later, maybe. I don't know.
if every startup, like, but the problem is to even to know, like, we know what the app's entry point is, right? Like, we know what the main activity is, but
Theoretically.
even theoretically we know, but it's more complicated because your application class, could have like activity lifecycle listeners that like mess around with activity lifecycle. It's worse that you can have, because you can have large dagger graphs being created as a result of application on create, right? So identifying the parts of your app that are important during startup is actually like not easy, because we can identify some stuff, but there are many cases where we'll miss something just because we don't know statically without executing your code as to which parts are hot versus not.
You have stuff like the startup Android X startup library where
Yeah, you have a startup library that's running a bunch of initializers. There's all sorts of like goop at startup that happens, right? So uh, there's there's apps that load libraries that they don't have any idea as to what they're doing. For example, like if I use I'm not going to name the ad SDK, but like there's ad SDKs that do all sorts of like very gnarly stuff, download lists and like download ad slots and start bidding for what ads to be shown. There's all sorts of stuff that happens during startup that you should be that's hard for the runtime to reason about. And it's more complicated than that, because so far we're assuming that every time your process wakes up, there's some UI being shown. But there are many instances where the process is woken up where there's no UI being shown. For example, when you're running a job, right? So those cases are also important. And we have to like know what kind of startup you're optimizing for to a certain extent.
So yeah, I mean, there's also, I was thinking other cases where your process might be running without showing any UI. If you have like a media playback, or if you have a widget, or
right,
any million of numbers of things that you might be doing, and those are the things that maybe you implemented the widget 5 years ago, before it was cool, and then you forgot it exists, and everyone forgot it exists, and then you go and manually optimize stuff, and you're like, oh, I forgot that.
It's really not. I mean, it's not very straightforward to reason about app startup. And I look at traces every day, and I'm surprised by the stuff that shows up in traces. And you're like, oh, why were they loading this file at startup? No one knows, And then you're like, oh, it's like putting a sleep, and then you're removing the sleep at later point in time and saying, hey, I fixed startup by fixing a bug that I introduced, I don't know, a few years ago. So,
yeah. I mean, that's the best case scenario, when you actually manage to fix it.
Yeah.
It's called job security.
Yeah, that's for sure.
All right. Maybe you should get started with some code at this point.
Yes.
So let me spin up Studio, and tell me if you can, if I need to bump up the font size a bit.
Yeah, ideally I found that 18 for the UI and 22 for the code.
Okay. Oh, 18 for the UI and 22 for the code. Okay.
Yes.
Okay, I'll set this to 22. Just say font.
Appearance and behavior. Yeah, okay. Appearance. Yeah, that one.
And then
custom font. Leave the font. Just change the size. 18.
Just 18.
Yeah.
Okay. Is that better?
Yep. Perfect.
All right. Ignore this. I don't know what's going on here. I think Gradle's just unhappy.
Does that? Yeah, it does that.
All right. So we're using an app called Bundle, and Seba can describe what Bundle is a bit better than I can. So maybe you should describe what it is.
Long-time viewers will remember that we used to start, when we started this thing, we were building an application and learning Compose by building it. And then we kind of got sidetracked into talking about interesting stuff with interesting people. So we haven't coded as much on the app. But the idea is that it's an app that during specific times of the day that you tell it, it will hide the notifications you get using a notification service, and just show them in batches. So you can say, oh, show me the notifications every 15 minutes, for example, so that you only get notified every 15 minutes. That can be useful if you have like many things coming in at once, and you want to be able to do like Pomodoro timer or something like that. So that's the idea.
All right. You can actually maybe so here's a screen share. Basically, like I'm running a Pixel 6. This being where I turned on device mirroring on Studio, so you can actually interact with the device. I'm using Flamingo, so I can use some of the new shiny features in Studio to actually do this. And if you launch Bundle after you do the onboarding screen, which basically gives the app notification listener access and a bunch of other stuff, you get the screen. And right now, there's like one active notification which says USB debugging is available, and there's a few properties, and it lets you set up what your active
Oops, that's
time
broken.
ranges are. Yeah, that's
Dark theme has been thoroughly tested.
yes.
By nobody.
And okay, so that's where we have. So that's what we have. So this is, and the app seems to start up pretty fast, right? Like I'm killing the process, but we don't have a way. So I think the first problem that we're going to solve is like, how do we actually measure app startup first? Because
that was the first thing that I was about to ask. Yeah, but
yes.
how fast?
How fast, right? Like that's the question.
What do you mean fast? Okay, I want numbers.
All right, yeah. So I think that's
Faster?
the first question. I think that's the first question anybody's going to ask. And Bundle is using it's using Compose, as you can tell from the libs that are being pulled in. So let me scroll down. And yeah, you can see that it's using Compose and Compose UI and a bunch of other stuff. So right now we're running the debug version of the app, but we can actually change that if we want. So if you're doing anything with Compose, if you're doing any performance work, then you should always use a release version, because there's lots of stuff that R8 can do to optimize the code paths that are invoked by the runtime and UI in general. And it there's a lot of optimizations under the hood. So and also the one other thing that I've changed is I'm using main activity as the entry point. I've like defined that because for some reason Studio would pick the glance version, and I don't want that. So that's the only other thing that I did. And let's leave it at that for now.
Oops. Oops.
So if I run the app, right, like as you can tell, this is being built. Okay, this is this. You can tell this is real because now I'm bringing up a Gradle daemon. So now that we, so let's wait for the compiler to generate the APK and install it. At this point, I'm just running the debug version of the app, right? And it'll eventually launch once Gradle is done installing the APK. So maybe let's wait for that. Okay, it's done. So now we should see the app launch soon, hopefully.
And this is where nothing works anymore.
Oh, come on. Try again.
What the hell?
Try again. Be. You have
Okay,
to
there we go.
Yeah,
There
I
we
told
go.
you. First try.
Okay. Okay. So so we have that, right? So let's actually look at the build.gradle.kts. So here we have our Android block that defines the compile SDK, the default config, and a bunch of other stuff. What we want is we want to introduce, and all Android apps have two variants, right? There's the debug variant, and there's the debug build type and the release build type. I have to be very careful with my nomenclature because someone from the AGP team is going to be very upset that I called it a variant. So let me just say build types, and I'm going to define a new build type. So I'm just going to say create. And this is totally not rehearsed, right? So if I don't work with Gradle KTS generally, so if I make a mistake, I'm sorry. We're just going to figure it out. We're just going to figure this out together.
It's okay. I mean, you're already doing much better than I usually do. So
I mean, at this point, I will be on Google search looking for the snippet to copy paste from Stack Overflow. So you are golden, my friend.
and then you copy paste it and you realize it was for the previous version and the API has changed, and so you're on your own now.
Yeah,
and it's also groovy, so it won't work.
So okay, what I'm doing is I'm creating a new build type, which is called benchmark, because this is the target flavor. Sorry, this is the target build type I want to use for benchmarking, and I want it to have a few properties. I want it to is minify enabled is true, because I want it to actually it's not groovy anymore, so I have to use
Yeah.
equal tos. So so I have to say
Now
is
it
minify
looks like real code.
and then I have to say debuggable is false, because I actually don't care about debug. Okay, it's debuggable, false. And then I can say, so yeah, so basically I'm saying the reason I pick debug is because I don't want to deal with signing. Debug builds are signed with the default debug.keystore, and I can just change debug's properties and like get something that's close to a release build that's signed by the debug key store. So it's like it makes your life a lot easier. So that's kind of why I'm starting with debug, but then I'm changing the traits that I want to. So a shrink resources equal to true as well, because we want all the optimizations to kick in. But
so you are basically running like prog array whatever to make it look like a release build, but it's actually signing in with a debug key.
That's right. That's right.
Okay, fantastic.
Yeah. So I basically said, enable minification, disable debugging, and then shrink resources when possible, right? And so we did that. Now, if we just did this and left it alone, what will happen is R8 will then rename all our symbols and generate an obfuscation map, right? When we were doing performance work, it's really nice to not have to deal with obfuscation at all, because you just want to look at the source symbols and get to the source of the problem, and then you can rename symbols later. Renaming is sort of an orthogonal problem to performance, while it adds some more performance benefits because symbol names are smaller, and a few of those important traits are. But while there are still important optimizations that can be enabled with minification, full minification, with including symbol name shrinking, we don't want that, because for our performance work, when we look at traces or when we look at other things in Studio, we just want the full symbol name if possible, right? So for that, what I'm going to do is I am going to create a progart file, and this progart file is don't.pro. So I'm just going to do that, and I'm just going to say don't obfuscate, right? That's just a single rule that says don't obfuscate anything, and I'm just going to say progart rule. I actually don't remember what the progart thing is. Hold on.
So I feel much better about this now. It's because I always have to open Doc as well and copy paste stuff and be like, that's how you do it.
Yeah, so I always forget
Sorry,
this.
but there was Schadenfreude was very high at some point. I was like, yes, I'm not stupid.
It's not Schadenfreude. It's more like a kick in the balls of imposter syndrome.
Yeah, also that, I survived another day without feeling like a trap.
Okay. So I use this don't obfuscate.pro, which has a single rule that literally says don't obfuscate. Let's sync, right? Let's see if Gradle's happy. We'll know in a bit. So let's
please, Gradle, be happy.
All right.
Yay!
Yay! All right. So that's pretty decent. So far, so good. I mean, we're not out of the woods yet, though. So let's actually like build the app, right? So let me actually change the font here as well. Let me. Can you see that? It's better.
Yep.
And then I can also do the same thing here. Oops. All right. Just close this guy. Okay. Okay. So far, if you see, we've added don't obfuscate.pro. We've also changed the build.KTS, right? So if this is literally what I've done so far. And now let's just do what was I going to do? Oh yeah, I was going to build it. So let's actually do Gradle W tasks, right? Just to see if we can basically build stuff from the command line, because this is where things really get interesting. So once we do that, we should see benchmark show up somewhere. Like if you see install benchmark, that means it's like our new configuration, our new build type has gotten picked up. So let's actually assemble benchmark, right? So let's do app assemble benchmark. And what assemble does is it literally builds the build type configured that we configured. But I'm pretty sure this is going to fail in a bit because there's one other thing that we probably need to do that I did not do. Let's get to that part later. Like we'll see things fail, and and then I'll show you how to fix it too. So what typically happens is now you've configured the build type. No, oh yeah, there we go. So
it was this close. I thought, no, he's wrong. He's gonna build. Damn it.
So there are some things here. So like basically, there's a pretty helpful error message, which is not very normal for Android. Like Android error messages are generally unhelpful, but in this case, R8 messages are actually quite helpful. There are some references to classes, to some security classes that we don't directly use, but R8 is being super pedantic about them, and they've given us a handy mapping file. And I'm basically going to copy a few things from the handy mapping file. And like if you can't see that, don't worry, I'll show it right now. It literally says when R8 can't find these names, literally I couldn't care less. So I'm just going to say don't warn for these classes.
Oh, nice. I like the YOLO attitude. Yeah, sure. No. Yeah.
And this is typically what happens when you're dealing with the code base that you're not super familiar with, right? So I have this is the first time I looked at bundle. I have no idea what the app is doing.
Yeah,
and I'm like,
follow the red is a pretty good way of dealing with this.
Suppress everything. Suppress all the warnings.
So yeah, so what I'm doing is probably a bad idea.
Revisit this later.
Yeah, to do.
Comments. To do. We should check this later.
Yeah, check this later. But like, let's actually make progress. So this time, let's actually assemble benchmark and see if R8 is happy. So if everything works, then we should see the minified APK. The fact that you can see the minified task running is actually a good sign. That means R8 is doing its shrinking and all of that. And so let's wait for the build to complete. And let's see. Come on, Gradle, you can do it.
But this is good. I mean, Aurelio in the chat sent me a screenshot today. A build took 32 minutes. I was like, yeah. I mean, you can almost squeeze an episode of Game of Thrones in there. I mean, it's
okay. So if you saw this, we actually managed to build the project, which is a very good sign. So far, so good. Let me actually get rid of this stupid window. Okay.
No.
All right. Okay.
Oh no, that was the load-bearing window. Now the whole OS will collapse.
That was the pillar of everything.
So in the app, you should have outputs folder, and in APK you should have benchmark. And if everything goes well, you should see the app benchmark.apk. This is the APK that we built as a result of build type, and you should be able to open this in APK inspector, and you should be able to see the contents. And if you notice something interesting, which is that the symbols haven't gotten renamed, right? Like all the UI, like you can actually see things have the same names and the methods have the same names. That's because we turned off a bunch of obfuscations. So that's something we don't want. So this part is good. So far things look promising. Okay, now next step is to actually verify that when we launch the so if I switch from assemble to install, and I'm basically saying, take the APK ADB install, right? Which is what and Gradle has a handy shortcut for that. And of course Gradle is going to rebuild everything because whatever.
You touched something.
Let's go back to running devices, and hopefully it should. Okay, it installed it. So if I go back to bundle, this time it's actually using the release variant. This is using the special variant of bundle that we built, which is sort of nice because it's still the same app. Things haven't broken, so far so good, right? So what we've done so far is we've created a new build type, and we've made it benchmarkable. We're not out of the woods yet. So now we have a build type. We have turned off obfuscation. Now we want to measure things from this. Now things can be measured from this install, right? So that's good. One other thing that we need to do is we need to make the app profilable. And what that means is if you go to main and if you go to Android manifest.xml, in the application tag, you need to set profilable Android shell equals to true. This is basically a directive to the operating system that this app wants to be profilable. So you need to include high resolution traces, and you need to include more debugging information when Perfetto is running and like tracing the app. So makes the app more profilable from the perspective of the system and from the perspective of the tooling. So if your app is not showing up under profiler, like if you're trying to profile an app from Android Studio and it doesn't show up, and if you can't see the process, this is very likely the reason why, just because the tools don't have the permission to profile a process. So
do you get any hint from the tool
Yeah,
set if you forget
actually-
about this? It's like the
actually,
internet permission or the add the activity to the manifest kind of thing.
Actually, it's a good question. Let's actually hold that thought. So let me not add the profilable, and let's see what happens. And so you can tell me if that's decent enough.
And we can open a bug if it
yeah.
doesn't happen. We open
Yeah.
a bug.
All right. Okay. So now we have the app installed on the we have the APK installed on the device. So we're kind of, so if you look at the if you go to android.com/benchmark, which is the landing page for Android X benchmarks, it shows you a few different things. So there's a few different types of benchmarks that you can write, micro benchmarks, and then there's macro benchmark. And I can tell you what the difference is. So micro benchmarks are benchmarks that you write to solve debates about what algorithms are faster. So if you're doing sorting, or if you're doing something that's like where you're trying to just figure out like which algorithm performs better or which loop performs better, it's like a very scoped, fine-grained piece of code. Like iterating through a for loop, or iterating through a data structure that you've defined, and you want to understand its costs. That's when you want to use micro benchmarks. But if you want to deal with macroscopic things on the system, like process launches and things that are interacting where multiple components are involved, and you want to look at like things from a macro lens, where you're trying to understand what is happening more generally in the system, and not with a microscopic lens on like what is this line of code exactly doing. That's when you want to write a macro benchmark. And a macro benchmark is what lets you do things like test for application startup or generate baseline profiles and so on and so forth, because we need a lot more control on the process lifecycle. We need to be able to spin up the process, shut it down, compile the application, do all sorts of crazy stuff to make all this information available to you. So, but if you read the documentation will say, oh, you should use the template. But here we're not going to use the template, because I actually want to show you what the template is doing under the hood. So it's not very magical, right? So again, this is not scripted. So if I make mistakes, then we'll
if you make mistakes, it's all right. We'll survive. Don't worry.
We'll survive. Yeah. So let's just add a vanilla module.
But I like the disclaimer. Don't try this at home. Use the template.
I mean, you can use the template. But I think it's, I feel like the template is what scares a lot of people, because they think, oh, I need a special version of Studio, I need a special version of Gradle, I need a special version of something, right? So I just want everyone to understand that it's not that hard to add, to basically like go off the beaten path a bit and to run benchmarks and so I'll just show you what it takes. So here we are creating an Android library module. And actually, what's the package name that your application used? Let me remember.
I think it's
not this one.
Dev. Yeah. It used to be dev.sebastiano, but I don't remember if I changed it. Yes.
So that's the namespace, right? Yeah. So let's actually go back to file new module, and let's create an Android library module, and we'll just call it benchmark, right? Or actually, let's just call the module name benchmark, and rather than that'll be the name of the package. Okay.
Okay.
And we'll use KTS like we did before, and we'll set the API level to 24, whatever. And then we'll set the bytecode level to 8, and we'll create the module. And it's going to add a lot of goop to the project. Let's just add it. It's fine. And it's kicking off Gradle configuration right now. So let's see what happened. Ooh. Oh no. What is that? Error resolving plugin.
It might have, because we're using the...
Aha.
Yeah, you
Alright.
probably want to copy most of that from the other.
Yeah, let's do that. Split.
It probably just got really confused by the version catalog.
Yes, that's what happened, which is fine. Let's do this. So let's
This is what you get when you use stuff that it's not even alpha. I mean, so what's this like?
No,
what's
it's
the
stable.
support with? Is already stable?
Version
Where?
catalogs
That's
are
not-
stable in Gradle.
But the support? Oh man!
Let's see what happened here.
Such a smart ass.
It can't resolve COM Android application, right? Okay, let's actually switch that to. Why is it even trying to resolve COM Android application?
I have no clue. Maybe it might have messed up the root build.gradle. I think it did.
That's right. It did something. No, it just included benchmark. Let's actually look at what it did. Hold on.
Yeah, but it's also the build.gradle.kts, the root one. Yeah,
that's what happened. Yeah. So which one is this?
the root one. Yeah.
Is root one. Interesting. Wow, that is a nasty bug.
Sometimes it gets very confused when you're using version catalogs. It's trying to be helpful. It's just like, you don't have that. Let me add it for you. But
in the wrong place.
Well, as far as Studio knows, it's the right place. It's just missing half of the picture because it doesn't understand version catalogs as well.
Which line is this actually at?
No, the root one. Just on the root of the repo.
I see. It's on the alias. It's on the root.
Yeah, that one.
Okay,
you can get rid of both.
Here you go.
Okay.
Boom, done.
All right, let's see what happened.
Try again. What are those projects? I mean, I can't remember anything.
Okay, so it can't find library, which is fine.
Yeah, we don't have it in the version catalog.
Yeah, so let's add it. Where is it? Library. Okay, plugins.
It's gonna be under Gradle plugins, AGP.
Yeah. That's what I'm looking for. AGP and application rate.
Yeah, right.
Let's just do that. Library is the same AGP version. I can spell library. And then let's just call it Android library.
Perfect.
Let's go here. And then let's go back to this guy. No, not that one. Okay, this guy.
Yeah.
Let's just copy the exact same thing.
Yeah,
Sorry.
it's easier to do that.
And man, I'm having to scroll a lot more because
you probably need Kotlin as well.
Yeah.
Okay.
Call this library. Okay. And everything else should hopefully be all right. We can fix the dependencies block later to use the catalog, but code in sight was not. I don't care. Let's reload this guy. I like how okay, it's doing something this time, which is good. Yay! Boom. Successful. All right, we added a new library. Okay, this was harder than I thought it was going to be, but not too bad.
Believe me, that's faster
that's the
than
motto.
what we usually do. So,
that's our motto.
I'm thinking about having you on every episode because this is the only way that we can put some code in this thing.
All right. So there's some stuff that's like out of date here. Let's just just change to 9.5 so we can. I hate looking at warnings in Gradle, so I'll try. And then let me add Android test implementation. So before I add stuff here, I should explain what I'm doing. And so right now we added a library module, and you might be wondering, a library module to write a benchmark doesn't really make sense, right? And the reason and you're right, it doesn't make sense at all. But what we're using a library module here for is basically what we're really interested in is the Android test folder. So the Android test folder essentially gives us a way to write tests that are not. If I wrote tests under the app module itself, it makes a bunch of bad assumptions about those tests. It installs the debug variant of the app, which I don't want. And it basically couples the installation of the test with the installation of the app, and it overrides my preferences every single time. And I don't have a lot of control through the DSL and through Studio in general, and I lose that. So that's why what I'm doing is I'm going to write my tests in a associated library module instead. And there's already one of these, which is a JUnit test. Let's just run this, and then we will see our test passing. So that's like a good baseline, whether the new module is actually working or not. So once I do that, yeah, go ahead, Seba.
I was just gonna say I like your optimism. You're gonna see it passing.
I mean, it should, right?
Come on, give the guy a break. No, but I like the
No,
idea.
I'm just based on my expectations.
We are overcoming the weirdness of having everything in the app module, creating a library module to actually use it, to bend it in a way that we can exploit it. I love it.
Right. So okay, our test passed, which is good. So far so good.
I'm jealous.
All right. So now what I'm going to do is I want to write benchmarks, and to write benchmarks, I need to make sure I have the right dependencies. So I'm just going to close all the other tabs, so it's easier for you to see what's going on. And I'll close this too. And so I'm just going to say Android, and because we're going to be writing Android tests, so I'm just going to add everything as an Android test implementation dependency. So I'm just going to say AndroidX dot benchmark, and I want to add benchmark macro JUnit1. By default, it picks the stable version, but I want to live on the edge, right? So let's go to Jetpack release notes. Let's see.
I want the one from my laptop at work this afternoon.
I want the AndroidX.dev snapshot.
Yeah. You want a snapshot? No, I don't want to go that far.
No. I don't want to push it that far.
Okay, so let's go to benchmark macro JUnit4. Let's find that. And so the latest version seems to be 120 alpha 7, right?
Alpha is legit.
So let's actually pick alpha 7. Now I know. So this is the latest version of AndroidX, and then that's all we really need. So let's actually sync. And once you have that, you have all the tools that you need to write the benchmark. Now you need to do one other thing, which so macro benchmarks, especially as you're dealing with baseline profiles, you want to make sure that the tooling that you're using is like fairly up to date, because we are continuously improving the tooling, and so some of the problems that you'll probably run into with old tooling have been fixed in the newer versions of either Gradle or Profile Installer or Macrobench. So I would recommend that you keep these three things, fairly up to date. Okay. So if you go back to,
can I update them like in a standalone fashion, or they have dependencies like then AGP is gonna yell at me, Kotlin is gonna yell at me, or they are cohese in their living together?
So I think the stronger coupling is between macro benchmark and profile installer, because we basically okay, I'll give you some more context. So when we are controlling the app, so what's going to happen is when we write a macro benchmark, we are writing a test, and our test is running inside a test process, right? But we are going to control the target app, which is bundle in our case, which is running as a different process using UI Automator. So we are going to ask UI Automator to reach across processes, and we're going to be, via UI Automator, going to be, like triggering critical user journey. So we'll be like clicking on buttons, swiping, doing all sorts of things on the target process. Now, to put the target process in some of the right states that we want some code in the target process that can like respond to macro benchmark's intent. So when macro benchmark wants to say, hey, I want you to clear art profile caches, then we want to be able to we need some code on the application side to be able to respond and says, okay, like I know exactly what you want me to do. I'll clear those caches. And then that way you get stable numbers. And so, and macro benchmark is actually quite helpful. If you use macro benchmark, but you're using a stale version of Profile Installer, like we are doing right now, because Compose ships with an older version of Profile Installer because it's a dependency. And so Profile Installer is already there in the APK. So if you actually look at the apps build folder, and if you go to the outputs file and look at the APK under benchmark, let's open this, right? Let's actually find in classes.dex file, let's actually see if we can see AndroidX.profile installer. And there it is, right? Like if you see P, where's P? Okay, I'm just gonna, that's not what I want. Okay, let's see. If there's a search here, that would be super helpful.
There is a bit, I saw it's there. It's like a bit in the middle
there
of
you
the
go.
screen. Yeah, there.
So yeah, so here's the profile installer library.
Okay,
and
so it's a transitive dependency of Compose, basically.
Compose. And the reason why the profile installer library is even a thing is I need to tell you something a little bit more. Okay, starting Android P, we have cloud profiles, and starting Android P, cloud profiles, the operating system knows that it can potentially download an additional metadata payload alongside an APK to download the profile information and bootstrap it if it's available, right? Let's say the crowdsourcing happened, we have a profile. When the Play Store downloads the APK, it downloads an extra payload that is aside from your APK, which has the profile information, and then it needs to deliver them both to package installer, which installs the application. So there are package installer APIs that know what to do with profiles, starting Android P. But in Android N, O, there's no such APIs. Instead, what we do is like a pretty cool hack, and I'm calling it cool in quotes because it's actually quite ugly, but I still think it's cool. What we do, so what package installer does on starting P is it copies the profile to a well-known location, right? It's like there's a well-known location on the device where the profile lives for a given package, and then it schedules background exopt. Or actually, it schedules a compilation right away because this is happening at install time, right? Typically on Android N, what would happen is these profiles would get written to a well-known location, and they would eventually get picked up by background exopt whenever background exopt ran. So far, so good. Okay. Now, what profile installer does, it pretends to be the just-in-time compiler and writes the file in that well-known location so it can be picked up by background exopt.
Sneaky.
Pretend?
Because the app has so that's all profile installer is really doing. It's taking the profile information and putting it in a place that Art can find it. So when background exopt runs, it's doing the right thing and your app ends up in the right state. Now, what profile install also supports is putting the app in the right state when you're benchmarking the app. So if you want to use profiles, given that you don't have Google Play installing the APK, you're installing the app through Studio and all that, you want to put the app in the right state, you need profile installer to help you to put the app in the right state, because profile installer will help you compile the app, make sure that the process is in the right state and all that. And so macro benchmark has this dependency on profile installer for a lot of like baseline profiles related things. And so if we just wrote a simple benchmark and we used some feature, if you wrote a simple benchmark using this version of macro benchmark, it'll helpfully tell us that, oh, the profile installer version that you're using is slightly old, so just update that dependency to this version or newer. It'll very helpfully tell you that. So let's actually write a simple macro benchmark and let's get that far, right?
I like that Gradle is even more YOLO than us, suggesting you, oh yeah, you can use the snapshot version.
Yeah,
I mean, this alpha thing is for like old people. I mean, a snapshot or get the fuck out.
All right, so let's actually let's actually write a trivial startup test, right? So let's actually call it trivial startup benchmark, and it's a class, and I'll basically copy the JUnit run with, so it's a JUnit, and then there's that, and then I can delete this because I no longer need this. All right.
By example.
All right, and then we can say fun startup, right? Like this is let's actually call it trivial startup, and this is going to be a test.
It was our only passing test, so there is a bit of sadness at the moment.
But now I believe in Rahul writing another one that will pass.
So I think so. When you're writing a macro benchmark, we're going to use a macro benchmark rule. So we'll say val rule equal to macro benchmark rule. Okay, and then we'll say get rule. So it's the JUnit rule, and so that's how you define the macro benchmark rule. And now you can just say rule dot measure repeated, and this is the entry point to macro benchmark. So it has many parameters that you can pass. So let's actually set, do some of the work for those parameters. So let's actually define a companion object and say that constant of package name equal to, what is the package name that we were trying to benchmark?
dev.sebastiano.bundle.benchmark.
No,
Yes.
that was that's the benchmark.
Oh,
But this is the app process that we want to benchmark.
that
So
always gets me. I always
me,
do that wrong.
App to benchmark, right? Let's just name it that way,
Yeah.
so it's easier to remember. And so we can say rule.measure repeated. We can say package name is app to benchmark. This is the app that we want to benchmark, and it has a few other things that it wants. So it needs the names of the metrics that you want to collect, the compilation mode and the startup mode, and how many iterations. So what the setup block is and what the measure block is. It's actually pretty straightforward. So let's actually say I want metrics is startup timing metric, because all we care about is how long it took to start up the process, right? And then we can say compilation. So we can say startup mode equal to startup mode dot cold. Cold means that the process was dead in the beginning, and then we started off. We forked the process from the Zycode, loaded the APK, all of that, and the application was not already running. And then we can say compilation mode equal to compilation mode dot let's just leave it at default for now, because it's not very important. Let's set it to one iteration, and then let's say a setup block is, we'll define our setup block, which is press home. Press home means that we are going to always start the benchmark from the home screen, so that way we have a good baseline. And then we can say measure block, of course I'm missing a comma somewhere, measure block equal to that. So now we've defined our benchmark, basically. So we are saying this is the app that we want to benchmark. This is the metric that we want. We want the process to be cold. We want we don't care about the compilation state yet. So I'm just going to say don't care yet. And then I'm starting from here, and I can say start activity and wait. And this will actually introspect the default intent, but that's not what we want. So we can say, we can define the intent, right? So we can say intent equal to intent. Then I can say app to benchmark, and then I can say that's the name of the class. So that's the package name. Hold on. Why is it? Yeah, okay, intent.component. Component name, app to benchmark. That's the name of the class. So we can say, remember we want the main activity here, right? Because
yep, it's the only activity we have anyway.
Yeah. So we will say that's the right. Let's actually make this a bit more easier to read. So that's the package name, that's the class name, and then because we fully qualified it with the component, that should be good enough. And then we can say start activity and wait, and given this intent. What this does is basically says it basically waits for the application to start up, waits for the first frame on the render thread to be drawn, and then it knows that it's done. So it doesn't need any more cues from the test to know that the test is complete, right?
So this will wait through the splash screen, because we're using the system splash screen. And then as soon as we start drawing a frame, then it says, oh, now I'm done.
That's right.
Okay.
That's right. So that's all it's going to do. So now we're doing this only one for one iteration, right? So let's actually run this and see what happens. Some things will break. We'll see what breaks.
Hopefully not.
This is a good cue to not use custom splash screens, because it will kind of fake.
Otherwise you're benchmarking how long it takes for your splash screen to show up, not the actual app.
The test failed, but notice the macro benchmark is actually quite helpful. It says, by the way, your application is not profilable, so you have to make it profilable.
Right? Man, I completely forgot that we removed it from the manifest. Bravo.
Yeah,
nice.
So let's actually go back to under manifest, and let's actually make it profilable here. Right? So it has to be inside the application tag. So let's actually make it profilable.
Nice. This is good.
And now that we've now we need to rebuild. So now we need to reinstall because we changed the APK, the target application. I'm just going to rebuild it and then redeploy it to the device, right? And this is the one thing that you don't get with the way that the module flow. If you use the standard template, what it will do is even if you change either the app target or the test, it will make sure that the device is in the right state. Except when you take over things and you do this custom, like because I'm writing my test as a custom library module, my test does not know that there's this implicit dependency on the application existing on the device. So I'm making sure that the application is always installed before the test runs. And so anytime I change the application, I just need to kick off a new installation. And so that's kind of why I'm doing this.
If you do install benchmark, it's the main app anyway. So yeah,
that's right.
Yeah.
So let's wait for that to happen, right? And so let's actually why is this not happy? Okay, never mind. I'm not going to fix it.
Ignore it. Ignore it.
I'm going to ignore it.
The path to happiness is ignoring warnings.
So I'm just going to make this private too. Okay. Sorry, old habits die hard. Okay, I'm still waiting for.
This is fast.
Okay.
All
right, we did it.
Boom.
Right. Okay, now let's read on this now. We're not out of the woods yet. Let's see what other errors there are. So
there's a question is, do we need to do this step even if we add, for example, a comment, or does it need to be a big change? I think anything that is impacting the built app.
So here's another error that you will see sometimes. It'll say, hey, baseline profiles aren't supported on this device version. And that's actually a very confusing error message, and I'll tell you why it's confusing. It's the error message is correct, but what you're supposed to do is not very clear. And maybe I should fix the error message because that's the one. This is my error message. So
you need to do
buy a new phone.
Yeah, that was my same. I didn't want to say it, and I just waited it because I knew.
Rahul, you could put a link to the Google store at the end.
Yeah. Like
so, what's happening here is. So remember how I told you that profiles are specific to a device version, right?
Yeah.
So profile installer knows how to convert. Oh, I have to digress and explain what's happening here. So when you build a baseline profile, you build a baseline profile that's tied to a specific platform version that's embedded into the APK, right? So we basically picked version that's targeting Android P, right? And so there's two files that are embedded. Actually, let's hold that thought. I'll explain what's going on here, and then once I do what I'm doing, it'll make sense in retrospect, I promise. So let me just make the changes first, and I'll show you what's happening, and then we can figure out. Actually, that may not be necessary because the benchmark APK should already have some things that we can look at. Hold on, let's see if it has. Interesting. Interesting. All right, let's just do this first. What version? Okay. Let's fix this problem first. Let's actually add the latest, use the latest version of Profile Installer. And let me go to.
We are not using the one that ships with Compose, but we are overriding it to use a newer version.
That's right.
Nice.
So I'll see there's P, Android X, PQRST, RSP. Okay, over here. Android X profile installer. I'm just gonna copy this.
Would you advise to do this no matter what, just to be on the safe side of adding?
Yeah, I think it makes sense.
The better version.
Yeah, just pick the profile. Let's see what we have. Profile installer. Let's see what the latest tip of tree is. Right. Let's that's this is the version we want. So let's actually. Of course, we don't have. This is TOML, so comments are. This is what we get for comments. So let's do this. So this is the name of the module. Actually, it's profile installer. And then we can say Version ref. Let's define a new version ref.
At the top.
Sorry. Aha. Then we can say PQR. Okay, right. Profile. Maybe. Installer. Okay, what was the version? It was
130
Alpha
alpha 2. Alpha 02.
Mm-hmm. And then we can go back here and change that. And then we can use this name.
Missing.
I think.
It's yeah.
Is that happy?
No, it's
Before the
outside.
module.
Yeah. Module equals was fine, but you need the open curly braces before module.
Larg. Okay. Module equal to?
Yep.
Okay. Yeah. Okay, there we go. So now we have that. So let's actually add this dependency to the app. And let's see what happens. Implementation. So let's actually do implementation. Oh, I have to actually sync first because it'll regenerate the libs. It'll do the autocompletion.
Yep.
Help for
so are you adding this to the app module or to the library benchmark module that we
need to add it to the app module because the app module is the one that's being compiled and that's the one that's being stress tested, right? So that's where profile installer matters.
Can we add it as an implementation dependency only on the benchmark type? So could it be?
You can, but I think it makes sense to add it in general because profile installer is how you get profiles on Android NNO in general anyway. So because cloud profiles doesn't exist, so you probably want to add it.
So also for a release is useful having it.
Yeah, I mean, there is also the fact that you already have it if you have Compose. So there is no, we are not saving anything, if you put it in another module. So Compose is still gonna put it everywhere.
What did we call it? Hold on. Android X profile installer. Okay, maybe.
Here you go.
Okay. So we added that as an implementation dependency. Okay, now that we changed that, let's reinstall our benchmark app again because now we have the new version of profile installer that knows how to support this profile. And so the reason why we need profile installer is because profile installer is the one that knows how to transcode profile information from one version of the platform to another version. So when you build a baseline profile, the version of the baseline profile that you embed inside the APK is tied to a known platform version that's targeting Android P. But when you want to install that version of the profile on other platform versions, we need to be able to upconvert and downconvert that profile to whatever version we are targeting. And the only component that knows how to do that is profile installer.
Got it.
Right. So that's why we have this tight coupling between macro benchmark and profile installer, especially with compilation, because profile installer is the only source of truth for what's the compilation state, how do we get to that compilation state, and so on. So this is actually good because this is exactly what you would do to know how to even get to a point where you can actually start benchmarking. So these are all the things that you will run into if you started from a project that had no benchmarks to begin with. So this is all stuff.
Out of curiosity, how different are the profile versions between each other? Like
they are very, very different. It's a bind. So you've looked at the human readable format.
Oh, right. It's a binary compiled version.
It's a binary compiled. Yeah, it's a compiled version. So we compile it. It's very efficiently encoded. I think we are trying to make a concerted effort to not change the profile format starting S, but the past is the past. We can't change it, right? So we have to support whatever happened in the past. So now that we updated profile installer and it's installed, let's read. No, that's not what I wanted to do. Let's sync again because Gradle thinks something has changed. So, and then we can run our tests again. So this time, let's hope that our tests pass and you should see something happen. Hopefully you will see the main activity launch here. If I got the component name correctly, I hope I did. Let's see what happens.
It should just flash though, right? It shouldn't stay there.
It should flash, and we can also we can also do something where we can say, we can say device dot wait for. Hold on. Let's actually wait for the compilation to kick in. But what you should see is just a splash screen. Once the splash screen is ready, yeah, see, he saw something happen, and then bundle must not be running prior to cold start. That's right. That's fine. That's because we were already running it. So now that so let's actually rerun the test. We can actually say kill process, right? We can actually kill process.
I like this incremental tuning that we do. That I love it.
Let's see what happens.
It's very artisanal. It feels like
what?
When you're
oh, I think this is because we have a notification listener service that's actually
but if you kill the process, it should not be running, right?
That's true. That's really weird. Okay, let's see.
Can you check if we still have the process? I mean, maybe we something running has been running forever.
Actually, let's actually see what's happening. ADB root. Let's actually restart ADB as root. Let's see what happens. Maybe yes. This is probably a bug that we just recently introduced. Okay.
There.
What is going on here?
Well, I want to be sure that the app is not running in some weird state because we have a service or something. Can you make sure that from settings that you just stop the app and then
I can do that. Yeah, I can do a force stop if you want, but I don't think that's the problem. I think let's see.
Humor me.
App info. Let's actually force stop, right? Okay. Let's see. Now we did a force stop. Let's go back home. Let's run this again. Although I'm not as.
Oh no! Sebastiano broke it. Sebastiano broke it.
Yeah, it does like it. I don't know why.
Oh, did we find a bug?
We probably found a bug. Let's actually do something. Let's go to the benchmark and switch to a stable version. Like, let's see what happens there.
Like a sane person would.
Yeah. Let's see if this is probably something we added recently to make it more foolproof, but maybe we didn't account for every possible condition that has happened. Let's see. Let's
Come
see.
on.
At least it's not blowing up. Yay!
Woo!
It worked. So this time we actually had the application launch and we saw a benchmark, right?
Oh, nice.
We saw some results. This is probably a bug we introduced in an alpha. I should probably file a bug. But
well, I mean, you also have the repro that you can just link the video, and you don't even need to create a repository. You just link the video.
Yeah, so
I can give you the timestamp.
I mean, it's also a bug for himself, so.
Yeah, it's
but traceability is important.
All right, so let's actually. So now, if you notice, we have the studio very, very helpfully report like logs from the device. We have benchmark results, and then this is actually like super nice because you get the results straight away in studio, right? What's even better, if you actually go to the apps, if you actually go to the benchmarks build directory, and you look at a folder called reports, actually outputs. And you look at connected Android device output. Notice there's a device here called Pixel 6. You actually get the benchmark results. The same thing that you're seeing. This is actually the text that the device sends to Android Studio. What's even more interesting is you get the JSON version of the benchmark as well. So you know what the brand of the device was, what version of the platform is running, what the all the details, and you actually get the metrics in a manner that can be parsed. So what macro benchmark is doing is it's basically reporting all these files as output to Studio, so you can link them in Studio, and this is also useful for CI. So if you want to know what was the result of those benchmarks, they end up in the build folder as additional test outputs essentially. So that part is pretty neat. What's even more interesting is there is this trace. And this is like the really cool part. So every benchmark, any benchmark that you
Oh.
generate comes with a Perfetto trace attached. So let's actually go to this folder. Let me open this folder in Finder. And let's actually jump into this trace, right? Like this. So here's the trace. Let me just move this window here. Let's jump to a browser, right? Like, and so let's go to ui.perfetto.dev. So this is
Okay. Nice.
so I don't know if I don't know how many people have used
No.
Perfetto. Maybe it's a bit intimidating at first, but like don't be intimidated. Just ignore the parts that you don't understand, and you'll slowly understand enough for it to make sense.
But we have a couple of questions about that, so maybe we can circle back then later,
Sure.
Sebastiano.
And let's actually just drag our trace and drop it in here. So you'll see like a lot of stuff already show up here, which is pretty neat. But what's interesting is there are some synthetic metrics. So you'll see all the CPUs here. There's like a bunch of CPUs, and these are like, and the colors represent what the CPUs are doing and what threads and what processes there are being worked on by that CPU as they're being scheduled in the system. So what Perfetto gives you is like a very high level view of the system, like in all its detail, right? And then you'll know what frequencies that the device is operating at. So you can tell that like I'm running at 5 gigahertz and my GPU frequencies are like 0.75 mega, whatever unit this is, I have no idea. And then you can see a bunch of like counters here, like GPU frequency, how it is being throttled up and down. And what's really interesting here is you will see
That's a lot of data.
Yeah, it's a lot of data. And then what you'll actually see is some other stuff here. Here's the app process, right? Like this is the app process, which is bundle, which is our app process. And what you should be also seeing is you'll be seeing something, an expected timeline and an actual timeline. I want you to ignore this for a second. So every time you see a process, you will see two things. You will see the thread states on top here, like this guy. These are all the thread states, and this is what's happening in the main thread and every single thread in that process. So as you can tell, this is the main thread because it shares the name of the process. So I'll highlight it because I want it to be shown here. And then there are some other threads that are interesting, right? So you can actually see well, I don't know. So this is Scion. Scion is basically I guess Firebase Crashlytics is what's happening here. I think that's what you're seeing here. Let's see what else. Yeah. So here you can see some work happening, and yeah, here you can see the heap size, right? And you can see the heap size is growing, and then at some point, and the way you Perfetto, you can use WASD keys. So you can actually like scroll left and right using WASD, and you can zoom in and zoom out as well using the same keyboard shortcuts. If you want to understand what keyboard shortcuts I'm using, so it's like W and S to zoom in and zoom out, and A and D to pan left and right. So like it uses, if you're a gamer, then you'll feel right at home, and it's super fast.
Now, Ivan's question is, can you kill Nazis in here as well?
Yeah, that's what I do usually.
So the cool thing
but
is,
this is a bit overwhelming, I have to say.
Yeah. It is overwhelming. To be honest, I'm not kidding. The first time I saw this, I literally closed the tab and I'm like, I don't want to look at that. That's it. Like,
so, ciao. There is a coffee machine somewhere here. Let's go.
It's Perfetto is essentially like systrace, but better, right?
Yeah, systrace, but better. Yeah, and you can see this is where the bind application started, right? So here you can see that. This is where we launched the activity. So this is where activity thread main happened. This is where bind happened. And this is where the application's activity start happened. And if you want to zoom in and zoom out, like if you want to zoom into a section, you can just press F and it'll center and zoom on that section. And if you want to see what else is going on, you can press M to mark that section and notice those like handy little lines that showed out on the side. And then you can just select that. And then you can see what other events are happening here. And then if you select the thread, you can actually see thread states now. Let me actually zoom in here.
Okay. Because the horizontal axis is time. I just realized that's actually time. Yeah. Okay.
And then you can see all the trace spans. And if you notice something else, so that's how you select it. And you can always click something that's outside and like this unselect your changes. And you can see all the names of the spans. If you wanted like every single span that so perform create is something that the platform adds on your behalf, but because I know profile installer is using startup, there should be a section for startup somewhere. So hold on, let's actually find that, right? Activity start is probably you should, yeah. So if you see startup, this is what app startup did, and app startup used is calling emoji compat initializer, and it's also calling profile install initializer, because profile installer is what is going to bootstrap the profile in the app process on our behalf, right? So you can actually see the trace sections, and profile installer depends on process lifecycle because it waits for at least one activity, it waits for like some amount of time. It doesn't want to interfere with the application startup itself, so it waits for at least a couple of frames to be drawn on the choreographer thread before it does something. So that's how you can see user-defined trace sections, and you can see how long something took, and and all of that. So it's actually pretty helpful. And if you want a good idea on what's happening, and if you see these icons here, they are basically binder calls, and you can see those binder calls are usually going to a different process, and it happens to be ADB daemon. This is because I'm using ADB shell commands to instrument something in profile installer during the context of the benchmark itself. So this is not as interesting right now, but that's how you can look at other things that are going on, right?
I think we're gonna have to do an entire episode just on Perfetto.
Yeah, this thing is super crazy. So either you come again, you come back again, or I mean, this is just I'm gonna just rewatch this bit forever on YouTube. But this is, I mean, this is cool, but I really need to know more.
And there's a couple of other things happening also, like in the app process, right? So if you go back to the app process for a second, this is our expected timeline, right? So this is all the threads in the process. If you see, you will actually find something. Hold on, it's JIJ. So these are the OKIO pools. Yeah, these are Firebase. You should see what I'm looking for. Finalizer heap class. Yeah, here's the just-in-time thread pool, right? Like this is actually cool. I want to add that, and I want to be able to. And you can see that the just-in-time thread pool is actually doing some work here.
So that's actually the Android runtime doing just-in-time compilation?
That's right.
Ooh.
So you can actually see things happening there, and and you can actually see more things happening somewhere down the line. Like I think in this case, you'll yeah. So here's all the just-in-time compilation happening. If when you zoom out, right? Like as the runtime knows more, it's doing a compilation here, and that's how you can see.
As soon as it has enough information, bam, it does another bit of work.
Yes. So like it's basically just-in-time compiling as it discovers hotpots in your code, right? So now let's go back to the app, and I don't know how much time we have. How much time do we have?
-8 minutes.
Oh gosh, wow! This took me a lot longer.
It's fine. You can come back.
Yeah.
Yes.
Okay. So let's actually change from compilation mode dot. What am I looking for? None. Yeah. So compilation mode dot none means I want you to start from a clean slate. I don't want the app to have any art compilation caches at all, right? That literally, so basically what it means is we'll clear all compilation caches before the benchmark, and when you run it, you will actually get the real worst case performance of your app. This is what happens after an install typically, and when you run this, it'll run the same benchmark. Of course, this is not super representative because it's just showing the initial launch. And notice that the numbers have changed. They were 300, low 300s, and now they've become 340, right? And I'll just show one thing in 2 minutes, and then we can end. So let's say you wanted to speed up this bit, and you wanted to say, I just want to speed up the initial launch of the app, and I want to write a baseline. I want to generate the ideal baseline profile for that. So for that, we'll just literally copy the same test that we wrote here. Where is it? No, sorry, not this. The benchmark module. Let me remove this. We'll copy the same guy, and we'll call it trivial baseline benchmark. And then instead of macro benchmark rule, we'll call it baseline profile rule, right? And then it'll be collect baseline profile. pack. And then you just need, we don't need metrics in startup mode and all that. We just need, what does baseline profile need? I need to opt in first of all, and then it'll let me.
You probably need to opt in the entire class because the rule is also complaining.
That's right, actually. Good point. So I'll just do that, and then I can say measure repeated, and I'll just move this code into a block. Basically, I'll say, right. That's it. So that's the only change I did. So I said collect a baseline profile for this, and I'll run that. And when that happens, what's going to happen is macro benchmark is going to start off with a clean slate. Make sure your application runs a couple of times, warms up the caches, dumps that information, and then takes the profile, converts it to a human readable file, and reports it via Studio. And so when that happens, you can click on this handy results link right here, and then you will see this is the baseline profile.
Ooh.
Boom.
Nice.
That's really it. And now you
have a lot of stuff. That's how you realize that your app is doing a lot of stuff at startup.
Yeah.
Right.
Yeah.
And I can end here, but if you want me to show you the performance improvement that you would have gotten if you use the profile, it's very easy.
Go for it.
Bye.
Let's actually go back to the app module.
The people need to know, Rahul. The people need to know.
Yeah.
So
also me.
So we'll create a baseline prof.txt here, and we'll drop it into source main, right? And what this should do is it should give Art enough. So I'll do assemble benchmark. I actually will install benchmark because. So when I do this time, because I provided the baseline profile information here, the result APK should include the baseline profile embedded into the APK in the assets folder, right? So that's something we should be able to see. So once the build is done, let's see, still running. Okay, let's finish our minification, and hopefully it'll have an APK for us that we can look at. Come on, you can do it.
Racing against the clock. That was the speed dance. Didn't help too much, but I tried.
All right. Woo! So, okay, we have the APK now. So let's actually look at the APK that we generated, right? So let's look at outputs, APK, benchmark. Let's look at this guy. So actually, I'm surprised it doesn't. Hold on. What is really surprising is that I don't see the assets folder anywhere.
Is it because it's very small?
No, it should be there, I think.
No, as in it's sorted by percent of size.
Aha, maybe it is. Hold on.
You should just be able to type, I think.
Wait a minute.
So it is not there.
That's really strange. Let's actually look at the actual. I don't trust APK Inspector. Let's actually go to the path, and then let's actually go to the absolute path. Let's open. Of course. Let's actually go to the benchmark folder. Let's copy this. I should actually do unzip -L on app-benchmark.apk. Let's actually see what it has.
And this is where we find it actually does not contain the assets.
Okay, it does not have the assets. Okay. Dang, that's very strange. I don't know why that is the case.
Cleaner rebuild.
We
It's
could.
Why
oh,
not?
maybe.
Why not?
I think hold on. Actually, maybe I messed up something in the Gradle file, because when I created the benchmark variant, I started from debug, and maybe there is something else that I missed that I should have done. So let me fix that bit.
This is the main app, right?
Yeah, the main app. So I'm just looking for the build type. So let me actually, init with release, and I'll do this, and I'll say signing configs. Get by name debug.
Okay, so now it's, instead of being debug but with optimizations, now it's release but with the debug key.
Key store, yes. There's a chance that that information is being used. Let's actually. All right. Oh no! I feel like we ran into another bug. This is what happens
when you use
The
stable.
demo effect.
when you use unstable versions. But
wait, didn't we go to the stable version?
No, we went to the stable version for Macrobench, but we're still using so we're using an unstable version of AGP and all of that. So I don't know if there's a way of not using them.
So what we learned today is that we need to file bugs.
Yes, a lot of bugs. I'm actually surprised. Hold on, why is it not doing it? Let's actually do something else. Hold on.
He's coming back so badly, Sebastian.
Yes.
He's coming back so soon.
Okay, let's actually just do an assembled release. And if this has the assets, if this has the right file, then I think there's something wrong with the way that I defined my build type. And that's I see merge release art profile happening, which means it's doing the right thing, actually.
Right.
So it's definitely something in my build configuration that messed things up. But let's actually see what happens when you add the baseline profile, right? Because this is actually useful to know, and we'll actually get the right answer this time. I'm guessing. Let's finish this. This I have a good feeling about this, actually.
Don't jinx it, man. Don't jinx it.
All right. Yeah, this is definitely a bug in AGP, because even though we initted with release, it's not copying or everything from release. So I'll file a bug with AGP, but it's not great, but it's not terrible. Let's see.
It is not the first bug that we find in thanks to bundle today, is it?
Yes. Yes. Clearly, there's bugs to look at. All right.
It's normal.
Almost done. This is okay. All right. Okay. Compile release art profile. This is actually a very good sign. That means that the art profiles are being packaged and all that. And now, hopefully, you will see assets somewhere. Assets.
There you go.
Yes. Assets. Dexopt. You should see these two
boy.
files. And these are, again, this is being converted back to the human readable file. But notice, so this is like what's inside the profile. And this is the prof.m. The prof.m file is the metadata that we need to convert your profile to every other version of the profile that we support. So you should see these two files in the APK. So now what I'll do is, now that these exist, I'll just install release because we can switch to that variant. What happened here? Install. Oh. Okay. Oh, that's because we have to. Dang it. Because of the key store.
Oh no.
Okay, hold on.
Should we just do just tweak release to use the debug?
Yeah. Hold on. How do you do this in
Named, maybe?
get by name? Yes.
Named.
And then let's just do.
Like this issue that we're finding is that we're seeing. The fact that we're seeing it live is great, because then the people that are using this and might have had this issue, now they know what to do.
There is the tutorial. There is a video tutorial now. Tomorrow is going to be a video tutorial on YouTube how to fix this.
Okay, this time I actually installed the release version of the APK with the profile. So now we have this. Now, ideally, so now we collected a baseline profile. Now we want to measure the difference that it makes, right? So let's actually move this function to a helper. Let's actually copy this and say, let's actually private startup. And then this will actually take a mode, which is a compilation mode, because we want to be able to control compilation mode, right?
Okay.
And then we'll do a mode. So now we care about this, right? And then we can say, we can just basically make this startup with compilation mode.none. And then we can say, I can add another test. And then we can say partial. This time we want partial compilation, and we want to say baseline profile mode equal to baseline profile mode dot require. Right? We are saying we want the baseline profiles to be used, and now we should be able to tell the difference between.
None is telling it to ignore the baseline profile.
That's right.
And partially say, no, make sure it's there and make sure you use it.
That's right.
Got it.
Well, it thinks no baseline profile was found in the target APK. Actually, one of them worked.
Yeah, the one without baseline profile worked.
Wait a minute. Oh, I think maybe I need to uninstall and reinstall.
dev.sebastiano.bundle.
Okay.
Yes.
I think it's because it did not do a full reinstall, maybe? I don't know. Let's see. Actually, we can also cheat if this doesn't work. I have another cheat, but let's actually run this.
I like the attitude.
So let's see what happens. Is it installed? What? Didn't we install it? Oh, is it because that the it's not dev, it's something else now? Is that the problem?
Is it?
Let's actually see.
Why?
Let me see.
No, but it was looking for the dot benchmark package.
No, but that was because the dot benchmark. No. Let's go back to running devices. Let's see if there's a bundle app at all. Like it's not there. Why?
Because you uninstalled it and it didn't reinstall it. Maybe.
Assemble. Oh,
it's not installed.
I'm an idiot. That's why.
Nah.
All right, it's doing something this time. All right. Okay. This is promising. Let's actually go back.
We also have people in the chat that know this.
Okay. That's all right. That's good. Like so, we have an app. We have bundle installed. That's good. So now let's do this again. This is what happens when I'm trying to rush the demo.
Sorry.
That's no worries.
This time it's doing something. Yay!
Yay!
Come on.
And see, it like improved it pretty significantly, right? Like it. So now, if you run both of them, and even for such a trivial thing that's all it's doing is showing a splash screen. If I run both tests together, and you want to see them side by side, so you can compare the results. Let's rerun the test, all the tests now, both the none and with baseline profiles, and let's see what happens, right? So this is running the baseline profile version now of the test, and let's finish for it, and then it's now doing the other one.
Okay, so this is the fast one.
It's the fast one, and that's the slow one.
Wow! That's a lot.
That's a 50%. Wow.
That's
That's a
huge
lot.
difference.
50%. Wow.
So yeah, like even for like such a basic example, I'm just like
And
you just
this is a tiny app. It doesn't do almost anything.
it doesn't do much, and
Wow.
notice we didn't have to change much about the app. We just like added a few things, we tweaked a few rules, and that's basically what we did, and that's
Wow.
how we got. And for bonus, if you go back to the actual perfecto traces, right? You will see the way that you can verify is if you look at the baseline, if you look at the trace that's the one that has the baseline profile, you will see fewer instances of just-in-time compilation kicking in, and that's because we moved all that work before at install time, and so it's not like the work. So it's like
So
the user perceptible differences.
You would see it in the trace if you started using areas of the app that weren't covered by the baseline profile, but
That's
you
right.
shouldn't
That's
see
right.
them or not as much.
That's right.
That's really cool.
Yes, and the cool thing is you can even click the trace in the studio in studio itself, and it'll open the profiler. Like you
Oh
noticed.
no, you didn't.
Yes. Let me
That's
import it.
amazing.
And so you can actually see.
Okay,
You can see. Yeah, you can actually see this profile traces
so
here
nice.
too.
Yeah, well, the
So
flame chart and everything.
Yeah,
Nice.
so we did a lot of work to make sure that like the writing the benchmark is actually like super. Like we try to help you and handhold you as much as possible, and so I'll end here. I know we're like way above time, but if you want me to come back for a perfecto or something else, I'm happy to. Yeah. So
you have to come back for sure. Like there's no there's no way around. You need to come back for sure because this is so. I mean, we need to do more of this. More apps need to do this. So we need to make it funnier and easy. So I love it.
There's actually a question from the slide, which is, should every app adapt baseline profile?
yeah, if there's apps that care about users, then they should, I think, use the baseline profile.
If you hate your users, just put a while true in your splash screen.
Yeah.
It's a sleep. It's a thread sleep. Okay, so we are running out of time in a very serious way now. So
Yeah.
I need to jump in and wrap up. Sebastiano, you have to
All yours.
I'm sorry.
You have
I'm
the
sorry,
floor.
but we have a hard schedule with VOD tomorrow, so no hard feelings. I just want to announce a couple of new things that we have on the store. So because we appreciate the support that we get from you, and we are preparing things like this. So we have a new metal pin, the Angry Pizza pin, similar to the keychain. You can go and check it out. I'm gonna leave the link in the description for YouTube. And we also have a new sticker for you. So check out the store, and thank you for the support. I'm gonna just.
I'm getting the sticker.
Yeah, that's so mess. That's such a mess. Wait.
Focus. Focus. Maybe. Can you
nice.
tell?
So this is the pin. If you are like a pin person, this is a metal pin. It's lovely. It's gigantic. And as Sebastiano showed, this is the most Italian Android sticker in history. It's the pinched hand Android. So you can find them on the store. We have a few of them, not much because we are giving them away at conferences. We should stop.
We've given so many of them away. I don't know who's gonna get them at this point from the store.
And anyways, if you want to support the stream, check out the links to support us with Amazon Prime. And Rahul, thank you again. It was awesome. You need to come back because there is so much stuff we need to talk about.
Yeah, happy to come back if you want me to. So
bye everyone. See you next week.
Bye.
Thank you again, Rahul. Bye bye.